I'll have it open. If I can find the... I have too much stuff open.
Can't you split the chat in its own window? Yeah, Papa, there we go.
Okay. Guys, the only thing, I think someone has audio on Twitch because I hear echo.
Yeah, me too.
Okay, now it's gone. Cool. No.
Yeah.
Yeah, okay, product. So this time we want to implement uniter. So right and left uniter. I don't know if it's visible on the blackboard. Let me see.
Oh, that's a really nice layout in the like for the call.
Yeah. Yeah. Okay. So basically, I'll write in a product that the uniter row on a component A is just defined.
Hey, Fab, maybe it's good to share a photo of your Blackboard.
Okay, let me try to do that.
Drop it in a Hackmd or something.
Yeah, the problem is that I'll take a picture with my phone and then I'll have to, okay, I'll take a picture with my phone and I'll mail it to you. Because I really don't have, you know,
I'll deal with it, yeah.
Yele, are you the one controlling the Twitch stream?
Yeah.
Because it's not showing up where, so two things. It's not showing up where Fab is typing. And secondly, I think you can change the camera to be only the camera of the Blackboard.
I see. So how, do you know how to do that?
I don't know by heart.
Show non-video participants.
But like instead of being the one who's talking, you select the Blackboard, and now the stream viewer should be able to see it.
Let me try and pin the video. So it's a bit on, what do we see now?
We see the Blackboard.
But we also see the laptop. Yeah. Okay. Is this what you meant, or?
Yeah, that always shows this camera.
Yeah, at the moment you can't see much because I'm taking pictures, so the Blackboard thing is probably just.
Yeah, I'll make it a bit bigger and then I can adjust the.
You can also put it on the left, since the left is only the file manager.
Yeah. Yeah, I was planning to switch off the file manager, but maybe it's good to keep it. So. Maybe like this.
Okay, I should have sent you 3 pics of the Blackboard.
Yeah, cool.
Yeah. Put this thing back here. Okay. So I always confuse left uniter and right uniter because they are basically the same thing. I've written row of A and product.leader, and that's taken to be just the projection, like this. So this is the component on A. And what we want to do today is we want to prove that this thing is a natural transformation and actually a natural isomorphism.
Just Fab on the Blackboard. Where is it? It's the I one.
It's the top thing. Top. Yeah. So it's this one and that one.
All right, and the other one is the other one.
So this square here is just a naturality square, which is actually very easy. Because you have the projection on top of it, then you have an F from A to B, and in here, that composition is by definition projection after F and then projection, because that's how we defined this thing the other time. And so if you project on the first component, you get exactly the other side of the diagram. I don't know if this makes any sense.
Yes, it does.
Wait, I need to look at it a bit.
So the thing that is in the square brackets is basically...
Yeah, you sequence pi1, F, and pi2.
Yeah, it's because it's basically this. You remember how if you have F and G, you can go from A times B to C times D using this diagram? Yeah. It's the same thing, but now B is 1, F is F, and the G is identity on 1.
It's the same thing, but replace G by identity.
Yes, exactly. And B and D by 1 and C by B. And then you get that thing up there. Because you have pi2 after G, but G is identity. Yeah. And then when you project on the first component, you get exactly the other side of the diagram, pi1 and then F.
Okay.
Okay, cool. Nice.
So, okay, I just need to find the correct files and everything, then I'll be there.
The correct file is in src limits product.leader.
But this is, I mean, shouldn't we? Yeah, okay, I think all these properties like refer to the product anyways, right? So we... Yeah, because you are defining... Yes. Because we're talking about the terminal object here, but yeah.
You're talking about the terminal object and the monoidal structure. So yeah, product and terminal object, yes.
Yeah, so we need both.
Yeah.
So maybe at some point it would be a good idea to like have a separate file for that, because
we can move some of this stuff on a separate file.
But I mean, let's just do it in product right now and then like think about that.
I think the biggest the biggest motivation for putting in another file is, will we save compilation time?
Yeah.
True.
Or rather recompilation.
Right. So we need
so I suppose
like left uniter.
Yeah, let me check before we get it completely wrong if row is the right one or the left one. The uniters. Let me see.
They could call it uniter and then have the opposite uniter.
So no,
or the other uniter.
The one I defined is actually row, and it's called the right uniter because a row is R, and lambda is left L, so it actually makes sense.
So I think we should put so let's see. We kind of need to assume now that our category has has products and
terminal objects
and a terminal object, yeah, and then like we should start with defining the arrows, right? So basically, like the arrow, like the left and right unit arrows are basically just projections.
Yes.
So, but maybe it would make sense to make like, what's it called? Not a namespace, but, or is it called a namespace in Idris? I don't remember, but like where we basically move in, we have this, this condition, like cat has products in line 71.
Yeah.
And then we also, like we can also make the same for initial object basically. And then we would say, okay, let's take like basically let's make a namespace that has like a category, and then which has products and an initial object, and then we talk about these arrows, because otherwise I think we like have to put 1,000 arguments and everything.
Okay.
But I forget the syntax. Let me look it up.
So this row sub A is like the left uniter thing.
The right uniter. Left uniter is lambda.
Oh, yeah, right, okay.
Ah, yes, okay. So
also, Fab, I have a question about notation, but you always put pi1 f semicolon f and then comma pi2.
Yep.
What's the difference between comma and semicolon?
Oh, it's because these square brackets are denoting the universal property of product applied to two functions.
Ah,
when I
okay.
And by the way, at some point, we really should prove the following identity. A second. Yeah. Oh, wait. Is parameters wrong on purpose? Okay, cool.
no, okay, yeah.
When I changed to parameters, it just like changed color. So I thought, hey.
no, it was a typo. Yeah, and so now I think we need to define like cat has initial object.
Yes.
Which, I mean.
Terminal objects, by the way.
Oh, sorry. Yeah. What? Oh, okay. There.
We don't have Idris REPL, by the way. How do you launch it? It's like with this Nix hand.
You can do Nix shell thing.
Oh, Nix shell, sorry.
If I do Nix shell, will it find it correctly or no?
Minus, yeah, exactly.
Nix shell, will it find it correctly or no?
Minus, yeah.
I think we're having some echo.
Yeah, a little bit.
Okay. I mean, yeah, it's a bit useless actually, because you could just write initial object. terminal. Wait, yeah, right. What? That doesn't work. Damn it. And then basically, like everything below that now has a category with products and a terminal object.
Mm-hmm.
And then
it has to be indented also.
Yes, yeah. Okay, and then we can basically now write down those two morphisms.
Yes. So I suppose the first thing we need to do is to obtain, like basically are defining the components. Rho A is a component of the rho natural transformation on A. Then we have to prove that the square commutes so that we have natural transformations. And I think that's it.
Yeah.
Now you need to prove also it's a natural isomorphism,
Yeah,
so you have the inverse.
Yes, that's the other, sorry, yeah, that's the other couple of squares.
Don't we have that already, kind of?
No. So actually,
but I mean, because it's like the projection on one component, right? It has to be. Yeah, I mean.
No, you see, it's here. It's actually not super trivial. Let me go closer. So one side is trivial because, yeah, it's that one. You start from A, you go to A times 1, you go to A, and if you project, that's the identity by definition. But when you go on the other side, you basically need to use the fact that the unique morphism to the terminal object coincides with the projection on A times 1.
Yeah.
And so you have this square, which is a little bit more complicated. It's nothing compared to that monster there that we'll need to do at some point, but it's still like not super, super, super stupid.
Okay. I mean, we already know that product is a bifunctor. Like, do we get something from that already? That's kind of the question I'm having.
I don't know.
I mean, that might save us some work, but probably not.
Well, we have to use the fact that product is an applied functor because rho has to be a natural transformation, and basically rho is going from the functor that does this to the identity functor.
Yeah.
Someone linked to an Agda implementation.
Yeah, I've seen it. Yeah, so what we actually kind of need then is that basically if we restrict a bifunctor to one component, then that's a functor.
Yeah.
Yeah, so, but okay. So do we want to, like, maybe we shouldn't call them row and stuff, right? Maybe like something like left.
Yeah, right uniter.
Okay, yeah. So this should be, I mean, maybe we can do the arrows like for now, and then do naturality later. So this would be, this takes an object, and gives us a morphism from
a product terminal object.
Yeah, and so we need to use probably, products, and then products takes 2 objects and gives us like the product. Okay, so, oh yeah, okay, so this needs to take A and basically
Terminal.
Carry of the terminal, yes.
Don't you have to use?
And then also a carrier here.
Okay.
And then we go to A.
Just where does products come from? Ah, it's the cat has product.
Yes. Yeah.
And cat has product?
It's just line 72.
Yeah, like
I see,
for
I see, I
all
see.
A and B, product A and B.
Yeah, okay,
Yeah.
got it.
So it's basically a proof that every 2 objects have a product. And then, so. And then how do we construct this morphism?
But I think it's probably better to, I don't remember how we defined natural transformations, but let me check.
Well, this is just the component of the natural transformation.
Yeah, what I mean is I think we should have things in a way so that then we can easily pack everything into natural transformations.
It's basically there's component and commutativity.
Yeah, I mean, you could like do something like that and that, and then like now it's called right unitary component, and then we can like have right unitary being the components, and then the proof.
So what I mean is that the record natural transformation depends on 2 categories and 2 functors. The component must be in a format that I suppose uses map obj of the 2 functors. So if we write things like this, carrier products, carrier terminal, I don't know if Idris is clever enough to understand that we are deferring to the identity functor and the product functor.
So you mean we should really like first?
Well, I mean that if we do things this way, it looks like less work now, but more work later.
Well, I think it probably can figure it out. So I'll just go on and maybe we'll just refactor the types.
Okay.
If Idris asks.
Yeah, I agree. And then, so this morphism is just the one projection, right? How do we get the projection?
From products.
Oh yeah, it's just product and then pi1 or pi2, I don't know, pi1 probably.
Let me see.
So
PR1, PR2, I think we called them. Oh yeah, no, pi1, pi2, yes.
Yeah. So this is, do I need to write the product prefix? Or do I need to write product? That maybe, and then basically the same, right?
Mm-hmm.
Product, A carrier terminal.
Yeah.
And yeah, that's actually it.
Okay, let's see. Oh, we didn't save.
Oh, so
yeah, I'm trying to reply to it.
Yes. Like Larry the Liquid, it's basically in an hour from now.
Yeah. Oh yeah, of course. We can talk.
Yeah, I cannot convert time zones in my head, but it's in an hour.
No, I'm more at a medium issue. I didn't realize like
Yeah.
I can talk to this stream. I have like two screens.
Yeah.
It's very confusing.
Well, the nice thing about saying it's in an hour is that, you know, time zones translation invariant. So, yeah, at least I hope so. Otherwise,
so we will take a break a little bit before, yeah, what is it? 4:30, 5:30?
4:30, yeah.
Yeah, and then we'll start.
Okay. So is this working up to now?
Looks like it, yes.
Yeah. Cool. So now we can either prove naturality or we prove that this is an isomorphism. I don't know which one is the fastest one. Probably isomorphism doesn't require to put, you know, to have functors around.
Where's the definition for isomorphism?
I think
isomorphism, basics isomorphism.
yeah.
Yeah.
Do we need that? I don't know if we need that. Oh yeah, I think we need it. Yeah. Yeah, so we should yeah, so I think now we actually should first go with natural transformation and then go from there, right? Because we can't really, I think we can't really do anything from here. So that means we basically need to prove that, so we have this product functor, right? Product functor is a functor from the product category to cat. Okay, so then we basically need to show that if we restrict to one component, then we still have a functor. Yeah, so this is now really not, this really doesn't belong in product, but maybe let's just put it in here for now and then deal with it later. Okay. Right. So how do we name it? Maybe like that. And then it takes category and well, I mean, technically we could go with 2 different categories, but I don't care about that right now, I think. So we take, do we call it capital F? No, we call it like functor. C functor. Cat product cat to cat. Yeah. Cat like that. And then
we want a functor from cat to cat.
Yes. But you also have to specify an object explicitly because you're fixing a component. Cat, yeah. Yes, and then this should be a C functor from cat to cat. Yes.
What's the second object we take in argument, like the last argument?
It's because basically you obtain a functor from a 2-component functor by fixing one component. So now
on the right, dangling.
Yes, on the right, you always have A and identity on A.
Mm-hmm. Yeah.
Yeah. So we should probably pattern match on the functor.
Mm-hmm.
And then from there, basically like make a new functor. Right?
Okay. Yes. Yes.
And okay, is there a good like way to like I know that in Emacs you can just do pattern match and works. I don't know.
There should be like Control-C, but I don't know.
I don't know if Visual Studio Code.
No, for me it's doing something different. Okay.
So well, let's just do it by hand.
Can do it manually.
So if you have map podge, map more, preserve ID and preserve composition.
Yeah, that was correct.
And here we have make C functor of A, B, C, and D.
Do you think you can figure out C and D without giving A and B?
No, he always complains we need to
it
define
always complains about C and B. Yeah.
Yeah, it will. Yeah. So, but I mean, how do we?
So we have to lift them in auxiliary function heavy type signature for them.
Yeah.
Well, I guess maybe they're not too complicated because map obj, we just take one object of the category.
Yes.
We need to take the product with the second object and then take the result of the first functor we have.
Yeah. So it would be like, I suppose, map obj fun. Like you give me an X and I give you map obj fun XA or something similar.
Yes.
You need to be given A as well, but we have it, right? Oh yeah, it's right there.
Yeah.
Actually, since you are taking the one on the left, I suggest to change this A to a B.
Yeah. That's nicer.
Yeah.
Yeah. So we should like basically so for the object map we take
an input, an object A of cat.
Yeah, we take an input. We make a lambda for the input, then make a here AB, and then plug it in map opt for for the original functor. Oh yeah, okay. So maybe the pattern match on the original functor actually might not have been necessary, but whatever.
Also, are you sure you can resolve which map object it's referring to?
This should be.
Let's call it prime and.
Ah, yes.
I don't remember
Universal
now the
solution.
notation, but.
And this is map obs of fun.
Apply to X and B.
Yes.
I don't remember if you used tuples. I hope we did. But...
Yeah, should be.
Yeah, because it's pattern matched down. Either yeah, exactly.
Ah, right. Sorry.
Well, it could be just that, right?
Yeah, yeah.
It's already matched, so yeah, we don't need it.
Good.
Okay, map more is the same thing, basically, but now instead of B, we put identity on B on the right.
Yes. Mm. Okay, and so now we take.
All right, I think that this doesn't work in a general case because.
What?
Yeah, because let's suppose I have this. So this is my functor, okay? It's basically doing this kind of game here. Now, if I plug identity of A here, I'll get identity of B here. But this doesn't get mapped to identity of A. Because when you have a functor in two arguments, the identity goes to identity only when you take the same identity on both sides, right?
No, this has to be mapped to the identity.
Yeah, but you see which one of the two? Like this gets, when you have products, this gets actually mapped to this.
No, I mean, this gets mapped to yeah.
No. Now we are going from
the product functor, that's what we get. Yeah.
We are going to this from, this is the functor we are getting, okay? But let me, oh yeah, but okay, yeah. Yeah,
So
yeah, no, true. If you have functoriality, it should work. Yes, absolutely, it should work.
So we take now map morphism, and then what? Okay. I map morphism is already for that functor. Yes. This looks good. And then the morphism we have. Oh no, we need like a pair of morphisms.
Yeah, we need a product. We need a product morphism.
Yeah.
So now we make more, and then.
Oh, you need it's product morphism.
What that is?
It's really called product morphism. Yeah. And then it has 2 arguments.
Yeah, I need 2 projections.
Oh. Yeah.
Where's the product morphism defined?
In product category.
Can't me find it. Product category. Ah, I see it. Yeah.
So something like that. Now we need to make a type check.
Ah, I see. Okay. It's the object of the product category.
Yeah. So.
What does make product? I mean, that gives us like this. Like, do we make product morphism?
Yep.
Oh, make product morphism is something in.
It's a record constructor.
Yeah. Okay. I was thinking that. Yeah, it would be.
The thing I don't get is that. Ah, never mind. I see. Okay.
Yeah, I was thinking about making morphism.
So now we need
Okay.
Yeah, let's see if that checks.
It does.
Woohoo!
Cool. And so now basically the proofs should just be like restrict to some component, but
should.
Yes, exactly.
It's going to be a fun equality proof because we are going to have to match on the product morphism, I think. Right?
Mm-hmm.
Yeah, I don't know.
Nice fine replace. Huh?
Cool.
All right.
That's fortunate.
That really works.
Nice.
Software engineering 101.
Yeah, okay, I think. Yeah, okay, I think I understand why, or at least like why there's a chance of it working. Okay.
Yeah, it's because ID generates a proof given its arguments. I didn't think of that. Wait, no, that's insane, right? I think it only works because we spelled out the whole type signature.
Yeah, I think so.
Yeah.
We gave an unbelievably verbose amount of detail.
Yeah.
So. Did we define the identity functor already?
Probably it's somewhere. Yeah, in functor leader, we've got ID functor.
Nice. Okay. Yes.
Yeah, this one won't be so easy.
Okay, that's a nice like change of pace, I guess.
Well, you should just be able to stick identities on the right.
Oh wait, it didn't work.
Yeah.
Okay.
Oh wait, no. I'm
Yes, and then you put F id B and G id B. So it's identity, yeah, cut B. That should work, I hope.
Yeah, that looks like that looks like we mixed up an X, Y, and Z somewhere.
these things look the same.
Yeah. Let's try again.
Yes, it really looks the same.
Yeah.
That's so weird.
Oh.
No, I'm confused.
Experience.
Like, can I disagree with type checker?
Well, you can.
It wouldn't be the first time either.
Yeah, you just say postulate and.
Yeah, these things are identical. I'm not sure.
Yeah.
What's going on here?
That's so strange.
Well, that is actually, probably is this. We have a id B after id b. And now in this situation, I don't know if he knows which identity law it has to apply. Because you can apply right identity law or left identity law to get to this. Know what I mean?
What do we need?
You mean in idris-ct B?
Yeah, like if I have an identity on B and I compose it with itself, we have two different laws that says that if you compose with an identity on the left, something happens. If you compose an identity with on the right, something happens. In this case, you can apply both. So if I suppose that if you apply one on one side and the other one on the other side, then you can have some kind of mismatch because you have two different paths to go from id B after id B to id B.
But I mean, that's then the complaint would look differently.
The what?
The like type error would look differently then.
Well, like if you look at the bigger thing, it says there's a mismatch between the mapmore xb-zb compose blah 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 and the mapmore xb-zb mk product morphism, which it expects. So we are giving it a composition, but it expects a product morphism already. So we need to rewrite like with the composition somewhere, I think. Or maybe not, I don't know.
Yeah, okay. No, wait.
It's just reporting the error in the wrong place, I think.
All right, can you say that again? In the big one, there is a difference?
Oh, yeah, so if you look at the big one.
Yeah, like it says, like there's a type mismatch between blah, blah, blah. So the second parts are composed, like these composed things equal.
But the error is in the first part.
But the error, is in the first part, and the first part is like on one side is xbzb compose product morphism xbyb product morphism ybzb, and the second thing is just a product morphism from x to z. So we need to like apply the composition law somewhere or something, or maybe not.
So what does this do?
Okay, yes.
Okay, yeah. Okay, I understand the error now. That's good. So basically, we need to show that the composition in the it's not able to like.
Hello.
Look at the types of TT and what. You see the difference? So basically, when you just need to...
We need to rewrite the fact that the composed identity is the
Yeah, we just needed one rewrite. And that rewrite is, well, the rewrite won't work because there's multiple identities. So we need to replace rather, which is a bit more shitty, but. So yeah, now this becomes messy. Replace TT, and we need to replace with the categorical. What is that law?
Left identity, right identity.
Yeah. Well, I guess any of them.
Yeah.
Now let's do left identity. Left identity on
Identity cut B.
No. B. Yeah.
Oh, B, right.
B identity cat B. And now is not gonna be fun. Wait. Wait, what? Identity. Oh, it's a left identity of cat. Yeah.
Yeah, I was about to ask, does replace the type in nested expressions?
Nope.
Oh.
It does, but you have to like do what I'm doing now.
Yeah. Mm-hmm.
No, you're writing. Oh.
Yeah, he's disconnected from Zoom.
What? I see he's still hanging around in the live share. So that's something, but all right.
How do you disable the minimap in Visual Studio Code?
I usually just open the command palette and then type minimap, and then it says toggle minimap. Can't.
And how do you open the command palette?
It's Control Shift P on Linux, and
Okay, got it.
Memory. I think it is Command-Shift-P on Mac.
Yeah. Great. I can't. Ugh, the line is too large and I can't see without scrolling. And I'm trying to disable the minimap to help.
But you mean in the current session, I actually disabled it?
Yeah, but it's not disabled in my editor. It's fine. It's fine to scroll.
Ah, okay. Like that. Yeah.
Wait, that type checks? What the heck? Wait, so Alex, you copy pasted the type signature into the implicit argument P.
Yep.
Is that right?
Yep.
What did you change?
Q, like you make so P is a lambda, right?
Mm-hmm.
And like its parameter like shows where to replace. So I've changed like that last part. Well, not the last part, but the here basically on the
okay.
left side, like I replaced.
On the right side of the product morphism.
Left.
Left
side. Sorry, left side.
Okay.
Left hand side of equality, like inside the product morphism, like this Q. You see it here?
Yeah.
So this is like what gets replaced with this left identity thing in this pconf thing. So
Yeah.
this is like a reverse rewrite. Like whenever you need to rewrite not in the goal but in the premise, you use this replace, and then it never can infer anything, and then you have to give it these p's manually.
Yeah.
It's like this forward reasoning. All right, so we're done.
I just can't believe it works. The line is like 200 characters long.
I mean, why not? Like rewrite like does the same thing. Like just rewrite is a bit more clever, and this P thing, it kind of infers itself, but in the term that you get like this TT term, like you get like you just don't see it here.
Yeah.
This is definitely some hardcore trickery, but
yeah, let's say that we are more like amazed on the fact that you can outsmart the compiler than.
Oh, I'm not that smart in him. I'm just doing its work.
You are the compiler.
Yeah, that's exactly what is amazing us so much.
Yeah.
Okay, now we should probably try to prove.
Actually, it's been an hour, so we should probably take a break until the presentation from Andre. Also, since you can't connect, it should be good if you could connect for the next 30 minutes.
Yeah, that's true. Okay.
Yeah. All right. I'll close this Zoom thing then, yeah?
Yeah.
I think you can just use the link again.
Cool. And so we come back at 4:30?
Yeah.
Yes.
I don't think we need live sharing, but I'll keep it open anyway because I'm going to try and carefully commit this stuff.
All right.
So, yeah.
So when do we start Andres' talk? 4:30?
4:30.
20 minutes.
23 minutes, yeah.
Okay.
Cool. Gonna buy a drink.
Yeah. Same here. Cool. This was awesome, Alex.
Yeah.
And everyone
nice
else.
work.
Yeah, great work.
Bye, guys.
See you in a bit.
Bye. See you in a bit.
All right. Bye-bye.